evening to one and all. I welcome you all to the fifth colloquy. Today's topic of colloquy is food processing in academics, research and food industry, current status and future directions. It's my immense pleasure to introduce today's speaker, Dr. KSMS Raghavarao sir, who is also alumni of our own institutions. So basically, he is a chemical engineer specialized in food engineering and biotechnology. Currently, sir is associated with IIT Tirupati as a professor of chemical engineering. He has also been a former director of CSRI, Central Food Technological Research Institute, Mysore. Sir has over 30 years of research experience, especially in food processing and biotechnology. At CFTRI, sir has worked in the area, like research area, especially aqueous two-phase extractions, reverse micellar extractions, or thermal membrane processing, fermentations, as well as coconut processing. Sir has been instrumental in designing as well as developing equipments, especially for the Indian traditional foods, for example, dosa, idli, chapatis. He has also developed like many technologies as well as processes. Just to name a few, like phycosagnin extractions from the spirulina, whole coconut milk productions. Most of the technologies are being transferred to the industries. Among that, virgin coconut oil technology is transferred to more than 60 industries. He is a recipient of many prestigious awards and fellowship. For example, Washvik Awards for Applied Research, National Fellowships of Academies. In addition, he has received National Award for Technology Transfer by the Ministry of Agriculture for virgin coconut oil. And Lifetime Achievement Award by the Andhra Pradesh Academy of Sciences, just to name a few. He has guided 22 PhD students in food engineering as well as biotechnology. He has extensively worked in the food engineering area as well as biotechnology, and sir has more than 620 research publications, more than 6,500 citations, 22 international patent, and more than 50 national patents to his credit. With this brief introduction, I would like to hand over this presentation to you, sir. Thank you, sir. Welcome to you.
Thank you very much. So now I'll go share my slides.
Yes, sir.
Yeah, at the outset, I thank ICT, especially Director Dr. Uday Annapure, for giving me this chance to interact with young faculty and young students, and also in industry fraternity. So UDCT has been my other alma mater. So as Sanjay was mentioning, I was a long time associated with CFTRI. But before that, I am at ICT. My roots are at ICT after graduation for my PhD. So that's why I put ICT, where I started my career, then moved to CFTRI, then I moved to IIT Tirupati. So all along, as she mentioned, it was more of applying chemical engineering principles for food and bioprocessing. The way food is very diverse and complex, chemical engineering also is a diverse thing, so they can fit into their, laughingly we used to say that we are jack of all trades but master of none. Especially in my case, I did not get masters because I did direct PhD at UDCT. So I attribute all my professional success to my mentor, Professor J.B. Joshi, and all the good students and scientists who have worked with me for their PhD. So because of that, all the credit all the recognitions have come to me. So I acknowledge that fact. So in research, especially for the youngsters, I would like to share that it is the innovation that is required. So the innovation, something new, what you are talking, what way you are doing differently, what others could not see, that is important. The second thing, and the speed at which you do. At a slow pace, if you do, you will be in the race. So research is like you are on a treadmill. If you don't run, you will fall back. If you run, at least there is a chance that you stay where you are. So never look for quantity, just small amount is sufficient to give you the real fillip and real recognition. It is the quality that matters, not the quantity. So as I mentioned, I'm fortunate to have Professor Joshi. Food engineering is multi-dimensional, and our director that time, Professor M.M. Sharma, you always used to tell in chemical engineering class, cooking, half cooking is chemical engineering, not the other way around. So it was really true. At NIT Warangal, after postdoc from University of Colorado, I started food processing as elective for chemical engineering students. It is a destiny. Even at IIT Tirupati, the thrust area is food process engineering. Partly, I should thank Professor Uday. He has only mentioned that they are starting food processing engineering. They are looking for it. But actually, I went there to looking for a placement for my postdoctoral student who are in UK. But I ended up in IIT Tirupati. This is the diverse and complex situation of food processing unit operations, typical pilot plant at CFTRI. So this is the basic transport phenomena that we look at it that governs everything in processing. See, for example, heat transfer, conduction, convection, radiation. And in mass transfer, diffusion and mass transfer and movement and transfer is fluid flow, hydrodynamics, and viscosity plays the role. But the real issue is the interdependency. See, the interdependency, how the momentum transfer influences the heat transfer, how the momentum transfer influences the heat transfer. For example, you have a glass of water. In that, simply you put in the sugar there, it will take at least 60 seconds for the glass to get all the water in the glass to get sweetened. But if you take a spatula and spin it, it will happen in within 5-10 seconds. What is happening? What is happening is when you stir it, see all the particles are suspended in the system, and entire surface area, enormous amount of surface area is exposed for the mass transfer. Whereas on the left side diagram, you can see only the cross-sectional area is exposed for the mass transfer. That's why enhancement in the area will increase the mass transfer, and diffusion occurs all over the place. That means convective mass transfer superimposes on the diffusive mass transfer, and overall mass transfer increases. Similarly, when you are in a hurry, you rotate your coffee glass so that it will get cooled fast. Unknowingly, you are applying the principle. You know that rotating the glass will cool your coffee fast. Why momentum transfer increases the heat transfer? Because from the heating zone, the first layer of the liquid elements in the first layer in contact will get heated. Then by conduction, they have to come here. Then conduction, they have to come step by step. But if I do agitation, the hot flue element is brought into the cold side, and the cold element is brought to the contact with the hot surface. So that's why the effective gradient, it's not the real gradient, but effective thermal gradient will increase, and my heat transfer will increase. So, but in food, the situation is a little bit tricky. It has protein, it has fat, carbohydrates, and a lot of moisture as well. The moisture during the processing, it will reduce, and so porosity also reduces. So all the properties like density, porosity, viscosity, and thermal conductivity, which are supposed to be assumed to be constant, will no longer constant. That's why mathematical modeling for the prior prediction become very, very challenging job. That is the tricky situation in food processing. So I take some of the case studies that to stimulate your interest, at least some of you pursue them seriously, the purpose of this talk will be considered fulfilled. So you must be knowing that fluidization is a unit operation in food processing or chemical engineering. The conventional chemical engineering fluidized bed, which is a vertical cylindrical unit, is not suitable for food systems because food has a food component. Food products have high moisture content, and they have a irregular shape. That's why this process becomes very energy intensive. This is the fixed first law, you are familiar. So the same thing can be expressed as N into Ka delta C. So now what is in my hand, delta C I cannot change because it is decided by the system. Mass transfer coefficient also I cannot change much because D is also fixed. What I can do is I can increase the area. So that's where I can play the role to get a increased surface area. So the first step towards that is, instead of having a complete cylindrical thing, I will have only one hole at the center and entire gas comes from there. The pressure drop is very less and it fluidizes only a fountain, and that material comes back and waits for its turn and again resuspends. This is called spouted bed. It is very, very less energy consuming. That's why we have applied it for some of the lab scale processes. For example, coffee roasting. Here, if you go into the market, this is the machine you find in a coffee shop where you will be roasting. Inside this, it is a conduction, high temperature, high time roaster. Once roasting is done, the material is brought in here, then he starts cooling, but without knowing the fact that already damage is done. That's why with the support of DST, a spouted bed dryer is designed and developed here, which has a transparent cylinder. You can watch the product. When the color changes, you can stop the process or increase the flow rate to get the product out of it on a convective board. So then another thing is, the only issue here is the scale. You cannot have a very big one. So, and it cannot be, it's not easy to make it a continuous. So at the best, it can be semi-continuous. So then the bed, cylindrical bed is made into horizontal, and this is a very, very thin bed is used. The thickness is order of magnitude of 10 millimeters or 20 millimeters. So even then, the fluidization is achieved by mechanical vibration using the springs. So the heat transfer is done only by small amount of hot air that is passing through. Even the hot air, instead of using indirect heating, directly LPG is burned and it is mixed with the fresh air and let in, and it has a lot of residual heat in it. It is recycled. So you don't believe, we have integrated here in this. This is a vibrofluid as a bed feeder. Then you have the first this kind of roasting system. After roasting, one more deck is here. There it is only no hot air, just it is kept in vibration so that some resting takes place. And in the third deck, instead of hot air, cold air is passed and the product is cooled. So at the end of the 3 decks, product will come out roasted and cooled. So especially this was done, this was necessary because most of the food products uses wheat, roasted wheat. The roasting is done by sand, and sand particles will remain in the crevices of the wheat particles, and many babies will get stomach pain because of the silica contamination. This is a hygienic thing, and also alternative use for fire. Instead of using diesel or petrol for the as a fuel, LPG gas is used for the as an alternate fuel. It is supported by Ministry of Petroleum, the project. Not only for, it can be versatile, not only for suji, that kind of product, wheat, soji, that kind of thing. It can be done even for the cornflakes, vermicelli, fryams. This kind of irregular shaped bodies also can be done. Essentially, the human being has a taste buds in the tongue. If you can pass the tongue, every product is acceptable. So instead of having a high deep fat fried high fat food, we roast this material and give a spray of oil. Product will have minimum oil uptake, say 5%, but still give the good mouthfeel. You can see both in terms of fuel as well as the cost. So this vibrofluidized bed is very, very effective. So then another thing is field assisted drying. Here again, especially the difficult situations like cashew, where the fat is very high amount of fat is there, that matrix doesn't allow the moisture to come out. So if you do the conventional heat transfer, so heat has to go from outside, then heat has to go to the center, then it has to evaporate the moisture, and moisture has to come out. Both heat transfer and mass transfer will be in the opposite direction. Whereas if I do in infrared, it on incidence, it releases the heat, both heat transfer and mass transfer in the same direction. This is previous vibrofluidized bed dryer, and other ones were done by Dr. Venkatesh Murthy, who has worked with me for his PhD, and also my colleague, Dr. V.D. Nagaraj. Whereas this was the work carried out by Dr. Umesh Habar, who has also worked with me for PhD, but on a different system. So then with the support of DST, it was fabricated in CFTRA workshop. Then a bigger project was applied, and a larger scale unit was designed, and this was clearly demonstrated that product recovery, product retention of nutrients are much better, and it's a cost-effective way of doing this. Then liquid concentration is, after drying, liquid concentration is another very energy intensive unit operation in food processing. So most of the fruit juices, for the sake of transport, ease of transport and ease of storage, less space required, they are concentrated. Conventional processing is thermal evaporation. Thermal evaporation itself has come a long way. Initially, it was a open pan, then falling film, rising film evaporators, state-of-the-art technologies, scraped surface evaporators, but still they have the product damage by heat. As I mentioned, this is the state-of-art scraped surface evaporator, but conventional practice is now at the moment industry uses reverse osmosis, because here water is removed as water without the phase change, so very, very cost effective, but it has a limitation. It can go only up to 25 bricks, above which the flux becomes so low and it is not feasible. That time it is switched over to scraped surface evaporator, and you will further concentration up to 70 bricks you can achieve. But still there is a heat damage. So we thought whether we can replace this hydrostatic pressure difference in the membrane, like reverse osmosis, with a osmotic gradient, because it has a serious drawbacks of concentration, as I mentioned, 25 bricks and membrane fouling. So these are the concentration polarization. All these drawbacks can be overcome if I replace my hydrostatic pressure gradient using an osmotic gradient. So osmotic gradient means osmotic solution is kept on the other side of the membrane, feed is here, and the moisture evaporates because this is a hydrophobic membrane, and it diffuses as a vapor and condenses on the other side. So it's a very good scheme. It is working very well for the removal of the water from 25 bricks to 70 bricks. But flux is low because there is a evaporation involved here. So then we replace with the hydrophilic membrane. Water is removed as water. Flux is at least 2-3 times higher, and we are happy that it is able to concentrate the liquids much faster way. But once you solve the problem, it will generate 5 more problems. That's how the research moved forward. So here the issue has become the back diffusion of the solute, because this is a high osmotic solution. These pores are filled with water. So by Fick's first law, there is a back diffusion, and I'm getting the salt on the feed side. But you may say, what is the issue? There is no issue if my feed is a vegetable juice, but definitely if I'm using a high value compound like picosanine solution or any other material where salt is not acceptable, it will be very objectionable. To some extent, we try to address this problem by using a mixed osmotic solute, where the part of the 50% of the solute is of high moisture, high molecular weight, so that bag diffusion is discouraged. But some of the things we observed were very, very intriguing and interesting. Normally, conventional wisdom tells that if the pore size is big, diffusion, the flux rate will be high. If the pore size is small, flux will be small. But what we observed is the flux is higher when the pore size is smaller and lower when exactly the opposite. So we used to have a Professor Kumar ISC Bangalore to teach us mathematical modeling. He used to tell us nobody believes the experiments except the person who has done the experiment, because he has seen with his eyes, and everybody believes the mathematical models developed except the fellow who has developed the model, because he knows all the assumptions involved. So like this, here we are believing our eyes, we know that it is correct, but we are not able to explain why it is opposite to the conventional wisdom. Then we went back to drawing board and found the answer lies in mechanism that takes place in the diffusion inside the pore. So when pore size is small, the kind of diffusion taking place is Knudsen diffusion. That means number of molecules are less, they are hitting the pore wall and traveling, transversing in the longitudinal direction across the membrane thickness. Each time the travel distance between the two collisions with the pole wall is high. Whereas in molecular diffusion, when the pore size is big, molecules are hitting each other rather than moving forward. So that's why very quickly the material is, water is, moisture is coming out of the membrane pore in case of Knudsen diffusion, even though pore size is small. Whereas here they are colliding with each other rather than moving forward. That's why there is a flux is low. It is exactly the crude example I can give is like when you go to a movie theater, if everybody stands in a single queue, everybody gets ticket very fast. You will reach the ticket counter very fast. If everybody makes a rush, rubbing into each other, then it will be delayed process. Same thing is here, and still the flux is low. Then we try to keep acoustic field to increase the concentration, to disturb the concentration polarization, so that I will get my higher flux. I don't know, for some reason animation is not working. This is the hydrodynamic concentration polarization layer between the stirrer and magnetic stirrer on the hot plate. I have put my acoustic transducer. These are the acoustic ultrasonication waves which stirs it and gives me higher flux. Then traditional Indian foods is another area where multinationals are not interested, or they do not have the required expertise. So that has been one of the major activity at food engineering. So, and nowadays, especially in the COVID situation, that traditional Indian foods have gained a lot of importance. So you can see here, this is a frying, which is a type of drying. So removing the moisture, but at the same time, you are adding the fat. So the vada is formed here in the hot oil, which is in the racecourse pond. And this formation unit is a cylinder, coaxial cylinder. So around the cylinder, it forms a donut shape vada. So this is the vadas. They will have a specific residence time, and each time while they travel in the path, there is a propellers which there is a dip below these paddles, so that they will turn around. That means they are exactly imitating what the grandma does by shifting the vada on the other side to frying. By end of 2 minutes, it comes out of the unit, and you will get a 400 to 600 vadas per hour. ID company, as you know, it is a startup started by some of the IIT young graduates like you guys. So they started the ID company and they are very, very successful. So they have taken the technology from CFTRI for idli batter and also for vada, but they have used their innovation. Just I was mentioning to innovation, they incorporated this formation of vada into the lid of the packet. When you squeeze the batter into the hot oil through that lid itself is having a center rod and a coaxial cylinder, so that it is dove-shaped vada is forming. Otherwise, nowadays the modern young girls, I mean, sorry, it is not a gender bias, but it is a fact. They are not equipped to do how to form these vadas like their mothers or grandmothers. So it is a very, very beautiful innovation, and that's no wonder ID is so successful. Now is coming out with much more innovative products into the market, including coconut, tender coconut water, coconut grating, these kind of things. So this is another product like that puri. Puri is a very good product, but it has 33% fat. So that's where it is no, we cannot call it as a health food any long, or it's not good. Not only health food, it won't qualify even for a good food. So then we took that problem and extruded using a pneumatically, forming a sheet and a rotary cutter so that you will get a squares. But actually, puri is round, but if you make a circle out of this, and the corners of the square will have to be recycled, but the rheology is changing when you recycle it. That's why we started calling it a squarey instead of a puri, but shape does not matter. But the best part is the fryer has a 3 limbs, 120 degrees at each. Each time, the one of the paddle will keep these puris submerged in the half turf oil. The oil is a minimum quantity you can manage here in this design of a fryer, and you will get the minimum uptake in the oil. The oil is 1/3. This is about 13% oil compared to 33% in a conventional, even grandmom style, if you do the puris. Why it is like that? Still, that the PhD student have completed his work. It has to be carried out at CFTRI or anywhere else to find out why pneumatic extrusion is giving a less oil uptake. And if you look at the regular puris, one side it will be very thin and one side it will be very thick, whereas here you will get equal thickness on the both sides. So that's how it has a not only energy efficiency, but also you have the what you call sensorial quality very high. Another area we have taken a deep dive is downstream processing. Downstream processing is an important area of biotechnology. People assume that once you produce it is not a big deal to purify it, which is not true. World over, many of the processes will not see the light of the day because downstream processing becomes very expensive. 85 to 90% of the cost of the product cost will accounted by downstream processing. So what is the issue? Issue is twofold. One is low concentration of the solute. The other one is presence of the contaminants. So many issues, even unused fermentation broth salts, all these impurities who are co-produced, all these are present. So that's why you have to use several unit operations: extraction, filtration, centrifugation, drying, crystallization. So many unit operations you have to use. Each unit operation, even though it is 90% efficient, if you have to use 5 unit operations, overall efficiency comes down to 50%. 90 into 90, 80, 80 into 90, 70, 70 into 90, 60. Like that, each time the overall efficiency after 4 or 5 steps, it falls down below 50, and productivity won't be economically viable proposition. That's why we proposed aqueous two-phase extraction, where entire downstream processing I cannot cover in this lecture. Only one unit operation of extraction I am taking and comparing. So conventional organic extraction, organic aqueous extraction is not suitable for these enzymes, which eventually find their application in food products. So because they denature it, and the solubility of these biomolecules is very low in these enzymes. So that's why aqueous two-phase systems are used, where typical case study I will take for the picocyanin. It is the race course pond. It is grown, it is harvested, homogenized. You will get a clear slurry, crude extract of algal Spirulina platensis. So picocyanin is a very high value addition because Spirulina is 30 rupees a kg, whereas here it is, once you purify it, it is 1 lakh rupees a kg. So different phase systems are used. Phase diagram, the chemical engineering concept of volume ratio and the equilibrium concentrations, tie lines, all these concepts are used so that you can concentrate into a smaller volume in a very concentrated way, so that I will get, even membrane processing itself is a very efficient way to concentrate, whereas here I am concentrating even without using membranes. Just by designing my aqueous two-phase extraction properly, I'm getting a much better extraction. Then another example is picocyanins, picobilivproteins itself. It has a combination of two picocyanins, like CPC and APC. Both are very close to each other, very similar. They have close boiling points. Very difficult to separate them using a conventional methods. Conventional method use precipitation, centrifugation, dialysis, ion exchange, chromatography towards the end. We thought whether we can simplify this downstream processing using aqueous two-phase extraction. To our surprise, we could get fractionation of this APC and CPC in a single step of aqueous two-phase extraction to our satisfaction. We could achieve the product which is much of higher purity compared to what is reported in the literature. So world over, entire world demand is met by Dinopong Inc., Japanese company, has a huge race course ponds of cultivation in Hawaii Islands. So when we say, one of our postdoc students, when I sent our product to them for price negotiation, after looking at the product, he did not respond further, because clearly the lab analysis in Japan has shown that our product has a higher purity compared to what they are producing. Another thing is the concept, new concept we adopted successfully is process integration to improve the productivity of these downstream processes. So see, what is the productivity? Productivity should be high yield, high purity at low cost. How to achieve this? The process integration can be done in two ways: inter-integration or intra-integration. Inter-integration means one after the other, ATPE followed by UF or RO or osmotic membrane distillation, or reverse micellar extraction, UF, RO or OMD, or intra-integration. That means multiple operations in a single step. ATP is that way is versatile to combine several steps like filtration, extraction, purification, and finally the concentration. I will take a case study to demonstrate this point. For example, I have algal cells. If I subject it to aqueous two-phase extraction, the cell debris will partition to one of the phases. Then the product will partition to the top phase. Then impurities partition to the bottom phase. That means in the first step, cells are partitioned here, I am achieving filtration. When it is product is going to the top phase, I am achieving extraction. My impurity proteins, which are impurities for my picocyanin, are partitioned to the bottom phase, I am achieving purification. Then, as I mentioned before, I can play around with the volume ratio and I'll achieve the extracting phase volume very less, so that I can get into a smaller volume of the top phase. So I'm getting a concentration which is membraneless concentration. Without the need of membrane, I'm achieving concentration by properly designing a single step of aqueous two-phase extraction. But as I mentioned, it is not true that all the things is rosy for a given technology. It has several bottlenecks. So first of all, it is a high cost of the polymers, phase forming components that are required for aqueous two-phase systems. So this is partly to large extent addressed world over by smart polymers, low cost polymers, so which will very easily separate out and can be recycled and reused. But another issue with the aqueous two-phase systems is for the extraction, it is because of the very, very low interfacial tension of these phases, mass transfer is very easy. It is not a mass transfer limitation. But the equilibrated phases, when they have to be separated back into the individual phases, that is a difficult thing. The slow demixing, the phase demixing is a very, very slow process. Why it is slow process? Because the delta rho, the phase density difference between the two phases is very low, and viscosity of the continuous phase is very high. So because of this, instead of forming a dispersion, the system is forming emulsion. You know the difference. Dispersion is in the absence of stirring, it will demix separately easily, whereas emulsion is a very, very stable. For example, milk. Milk is a very, very stable emulsion. It won't separate on its own unless you put a little bit drop of acid, change the pH, coagulate the protein, and it will demix. So then similarly, for the emulsion to break, we wanted a physical means. I cannot intervene using a pH. So we have done several external fields, electricity, again microwave, acoustics, different fields we have used. Electro-osmotic thing, our collaborator was University of Colorado. NASA asked them to conduct experiments in zero gravity, where zero gravity centrifuge will not work. So they wanted to conduct some extractions there using aqueous two-phase system, whether we can develop a method for doing extraction and phase separation without the need of gravity. So first thing it occurred to us, because there are salts in the aqueous two-phase system, they unequally partition between across the phase, and they develop Donan potential and Zeta potential. Zeta potential is the surface potential which gives rise to mobility of these droplets in presence of electricity. So we thought using electricity is the best bet. So in a cylindrical column, we have taken the aqueous two-phase system, applied two electrodes on either side, and applied the electric field. Phase demixing, when the top electrode is positive and this is negative, that we call as a normal polarity, positive normal polarity. So that worked very well, and we could get about 2-3 times faster demixing compared to gravity. We were happy. But as you know, most of the discoveries happen by accident. One day by mistake, we have kept the knob in the reverse direction. So bottom electrode has become positive and top electrode has become negative. Field is reversed. Then we found the demixing was 5 times faster. That means negative polarity is demixing faster than normal polarity. This is again, we could not initially explain. So normal polarity, there is a positive anode here, which is pulling the PEG droplets, which is having a negative surface energy. That is understandable. When I make this as a negative, then it is repulsing the PEG, is not allowing the PEG droplets to rise, it is holding at the center of the dispersion itself. Then how that is increasing the demixing? Difficult to explain at that point of time when we first observed. When we looked into literature, similar observation was made by Professor Brooks at University of Waterloo, Canada, but they just made a passing mention and left it. They didn't explain. Then we thought whether we can use our known hydrodynamic theories to explain this phenomena. We started studying what is electrophoresis. For a rigid cells and rigid proteins, this is electrophoresis. There is a surface charge, and depending on, because of the ions that are present in the system, double layer is formed, and this double layer will slide in presence of electrode, and this is something like squeezing action. Suppose how you eat your grape, you hold the grape in front of the mouth and squeeze the skin, immediately the pulp inside will jump into your mouth. So similarly here, this electric field is squeezing the this particle, and this particle is going into the negative direction. When the surface layer is pulled here, these negative ions are pulled here, this layer squeezes it, and my particle or the protein moves in the opposite direction. Why this is not so in droplet case? Because this is a rigid here, whereas this is hollow inside. There is a liquid inside. So this double layer is not only at the outer surface, there is a double layer inside also. This double layer also rotates here and developing a hydrodynamic circulation currents. Because of these hydrodynamic circulations, this dominates the electric field and it will remain in the center of the column until the coalescence takes place and they become big. Once they become big, as you know, suddenly the Stokes equation for the free settling velocity comes into picture. Once the coil, because of this coalescence, the droplets size started a critical droplet size of dp. This is a strong dependency of proportionality to the d square. So immediately these droplets will migrate to the top. That's how the demixing is much higher rate at negative polarity is used compared to positive polarity. So that's how we have solved the two paradoxes that is bothering the scientific community world over. What is the paradox? Paradox is truth but apparently looks false. What is apparently looking false? The phase demixing, the direction of the droplets is opposite to that is predicted by conventional colloid electrokinetics or conventional wisdom. So on the face of it, our observation is wrong, but we could explain based on the electro-osmotic flow model that I explained to you just now. And phase demixing rate increased irrespective of the size, and it is increased, the migration increased with increasing the size of the droplet. Normally size of the droplet increases, velocity should reduce. That is the conventional wisdom. But here we found that even droplet size is increasing, electrophoretic mobility is also increasing. Again, answer lies in this electro-osmotic flow model. Satisfactorily, we solve these paradoxes. But that is not only academic interest, we want to derive a practical utility of it. What is the practical utility of it? This is the conventional spray column that is used in the chemical industry. Aqueous two-phase systems of low interfacial tension, as I mentioned to you, they form an emulsion at the top. This emulsion, difficult to separate. So here what I'll do is, I will connect to this electro unit. So I have not shown here. So this one is subjected to electrophoretic separation, and this is one of the bottom phase is recycled back. At the bottom, we'll just use the inclined separator for the phase demixing so that the spray column can be used in a continuous mode without causing the problem of the slow demixing can be overcome. So I'm coming to the end. So this is the summary of several things what we have done over the years of research. There could be good contributions for the basic research because we resolve these paradoxes as I mentioned. Osmotic dehydration we explained based on the mathematical modeling, especially when you apply vacuum, why osmotic dehydration rate increases, that we explained based on the mathematical models. And all these traditional foods we designed based on the heat and mass transfer analysis. For example, take a dosa machine, which I have not explained to you. We showed that the type of heat transfer is more important than the quantum of the heat transfer. That means the heat has to be by conduction only. Then only you will get the crust of the crispy crust of the dosa and the porosity and the flavor that is developed. So if you hang dosa and give the same amount of heat by radiation, you don't get it. Similar thing we demonstrated through a tandoori roti. In the tawa, if I hang the roti at the center and give the similar heat by radiation, it won't give the same product. It has to be to the wall. It has to form that crusty bottom. Then only the flavor will develop. Then coconut, several PhDs have done on coconut. 4 PhD students have done, latest being Archana, and they developed a lot of products and processes based on the coconut. And about 19 PhD students have worked on CPC and other areas, phycocyanin and aqueous two-phase extraction, then modeling of drop formation aqueous two-phase system, phase demixing, field-assisted demixing, all this. So because of all the students' hard work, I have got a high H H index, and these awards already they are mentioned. And always teaching has been my first love. I have been teaching 30 years at CFTRI, and same thing I am continuing here. So these are the different topics that I have been teaching, and now I am introducing a new course, advances in food processing, food science, not advances, food science and technology, including advances at IIT, and also process integration and process intensification. That means application of external fields. These are the 2 courses I am introducing from this semester. And last semester, I took separation and processes and purification methods. So including all distillation, extraction, adsorption, all this. So we continue our journey, and I'm still in association with CFTRI. We have a MOU between IIT and CFTRI. Similar thing I look forward with if Professor Uday is agreeable, we'll be then happy to collaborate with ICT Jalna as well. So as I mentioned, innovation-based research is important. That is 10x principle we should keep in mind, all youngsters. Either you increase the performance by 10 times or reduce the cost by 10 times. Then only you will be in the business. Just doing some delta, small increments, incremental research won't take us long. Out of the box thinking is required. So all these paradoxes are required to break the myth and look into a new directions. And for example, we have applied acoustics for aqueous to phase demixing. But including our research council, they said, no, it is not possible. Acoustics will give energy to the system. How acoustics will give demixing? I could not explain, but it was my hunch that yes, it works. But because it's not approved in RC, I could not take up that work. When I went again for sabbatical, after spending 7 years at CFTRI, a couple of years again, I went to University of Colorado. There I tried using acoustic system for demixing. It worked. Then again, we modeled how that is working, because it is increasing the circulation currents. Those circulation currents are increasing the collision frequency of the droplets. Collision frequency increase is resulting to increase in collision probability. That's how the phase demixing has increased. So like that, so never feel that if you are having a hunch, whatever your heart tells, go by your heart rather than your brain. So you will be successful. So the future research, current research will be health and wellness foods. Because of situation like COVID, our immunity is the major thing. So nutraceuticals and functional foods, immunity boosting food supplements, automation in processing because energy cost is increasing all over the world, artificial intelligence in process operation and control, validation of traditional knowledge is also important, and multidisciplinary incubation and innovation centers are required. So I'm happy to announce my first project here of innovation and incubation center for food processing is sanctioned for 2.6 crores, and the construction and procurement of equipment starts in this month. Similar exercise I did at CFTRI. Many of our own PhD students have become entrepreneurs, successful entrepreneurs. That was really satisfying for me. I conducted a lot of industry, inviting industry and for their collaboration. Several startups were venture capitalists were identified, and this is my research group. So which has directly or indirectly has worked with me. Some of them are not directly PhD with me, but they are also in my group. So that's why we are all together as the extended family. My daughter is also here and my boss at home is also here. We have a small and happy family. Thank you very much once again for giving me this opportunity. I'll be more than happy if you have any questions or clarifications. It will be my pleasure.
Yes, thank you so much for wonderful talk, sir. It was always pleasure to listen to you, sir. And now topic is open for the questions. Student, you can go ahead with the questions.
It was pleasant to see Professor Pandit here. Thank you very much. So he was my friend, philosopher and guide at CFTRI, sorry, at UDCT and CFTRI even now. Yeah, please, any youngsters have anything, I will be happy.
Yeah, please don't hesitate to ask questions. And
Don't
sir
hesitate at all. I mean, if you are feeling hesitant, let me start asking the question here. I was quite interested to know about this acoustic demixing which you talked about.
Acoustic demixing, yeah.
Yeah.
Yeah, so what happens when you apply ultrasonication in megahertz range, it is imparting energy to the system and heat is also there and it is a high power consuming. Whereas if switch over the frequency to megahertz range, it is a very, very low power consuming and very low field it is giving. It is giving a mild circulations in the circulation, in the dispersion. So the collision frequency is increasing and collision probability is increasing, coalescence probability is increasing, and demixing is faster.
So basically, rather than using energy for acoustic cavitation, you use energy for acoustic streaming purposes.
Demix, yeah.
To generate acoustic streaming, which will increase the collision frequency.
Yeah.
We have also found out it may be as a function of geometry of the system that standing wave pattern gets generated when you have a free surface, when the acoustic waves reflect from the surface. Yeah. And the standing waves pattern, because of the Berkel's forces, have a segregation effect of shifting of droplets at the nodes and clean at the antinode. So you get different layers. You will find concentrated droplets or concentrated. And as soon as you increase the droplet density, the coalescence will get promoted. More larger drops are going to get formed and they will.
It is effectively used for solid liquid separation, agglomeration of solid particles. Yeah.
De-agglomeration. Thank you.
Yeah, thank you. Professor, you are looking a little bit tired.
No, I'm fine. I haven't had opportunity to have a haircut, and that's why I think.
Okay.
Come on, guys. Please ask. I think Professor
No problem.
Raghavarao has given you so many things which you have experienced it, be it dosa, vada, or dyes, and the operations which we talked about. You will be learning all these operations, especially the people who are going to look into the food technology or food processing and relate their basic chemical engineering unit operations to these particular steps or activities. And I think what he said, according to me, was very important. Is you have to think out of box and come up with innovative schemes or innovative ideas, innovative products. And please go ahead. And if you have any specific questions you want to pick his brain, please go ahead and pick his brain.
If you have any hesitation, please send by email. Still, I will be happy to reply them. Yeah.
Sir, you have questions in chat box. Shall I read for you that one?
Yeah, please do that.
Yeah. It is from Mahapara Khanam. It is she want to know, sir, what are the sub applications of ascortic demixing phenomena in food industries?
It's not directly in the food industry, but what happens is the enzymes what you are producing in aqueous two-phase extraction find in a food product. So that's where we are using, and also. The way sometimes in the food emulsions are required to stabilize or sometimes are required to destabilize. For example, coconut emulsion, coconut milk, I want to get a virgin coconut oil, I want to separate using without using heat, because heat removes the all value added products. So that time if I use acoustics, so it will demixing is promoted and emulsion is broken.
Excuse me, sir. I'm Joita Sarkar.
Yes, please.
Yeah. Sir, the machine, the vada making machine that you have made, so has the technology been transferred? Is it in market?
Yes. It is, technology has been transferred, and at least when I was there, safety area itself, about 6 industries have taken, including ID. I mentioned to you.
Oh, sorry, sir. As I mentioned that I was traveling, so I might have missed due to this network problem.
No problem. So I explained how ideas further used their innovation to modify that. They simplified into that dispenser itself, handheld squeezing they do, same phenomena they are used, so that very easily you can form the vada in the hot oil by squeezing the batter. In the lid of the packet itself, they incorporated this concentric cylinder and concentric cylinder and a shaft at the center.
Yes. Sir, I was just wondering, I heard that, if I heard correctly, that it makes 400 to 600 vadas per hour, right, sir?
Yes, please, per hour,
yeah.
yes.
So I was just wondering, isn't that a very huge number? And
no, it is not really, because what happens is application is not restaurant. Restaurants' orders are assorted. Somebody wants dosa, somebody wants idli, somebody vada. But it is in a huge canteens, industrial canteens and military canteens. Everybody want hot in a short period of time. That's where these missions have worked. For example, that Gashkov, that airline carrier from Russia, we bought it. There, for our ethnic population, CFTR has installed 6 dosa machines and 2 chapati machines and 2 idli machines on the deck itself for our military people working on the ship. So military canteens have been one of our major customers, and industrial canteens.
Okay, sir. Okay. Thank you, sir.
Thank you.
Yes, sir. One more question is there. That is like, how is osmotic membrane distillation is different from direct osmosis?
Only difference is the membrane. So there you are using a hydrophobic membrane. That's why moisture has to evaporate and diffuse. In direct osmosis is a hydrophilic membrane. Water is removed as water.
Yes, sir. And one more question, somebody want to explain you more about 10x rule, what you mentioned in your presentation.
What I mean is small delta incremental research will not fetch you. Youngsters have active brains, so you should go for 10x, either increase the performance by 10 times. This is actually I borrowed this from our former Director General, Dr. Mashelkar, who has written a pole vaulting, what is that? Pole vaulting than frog lopping,
Frog leaping to pole vaulting.
Yeah, for vaulting. So in that book, he uses this word 10x principle. So same thing I borrowed here.
Yeah, 10x is actually order of magnitude. At least one
Times.
order of magnitude improvement should be there. That is what you should aim for.
That increase the performance or decrease the cost.
Yes, one more question is there, sir. Slightly apart from your presentation, like, is there any specifications for analyte? No, sorry. How to prepare edible cutlery that are biodegradable? We can use any specific material for that.
So people are working, some are successful, but there is one Suresh Sakre and CFTRI, he tried with spent wheat bran and that kind of thing, but still I do not know whether it has reached the scale where it can be transferred technology. Even DFRL attempted, but the transfer of technology has not taken place from DFRL.
So one more question is there any specifications for analyte sample being extracted by using electro-osmotic model?
Electro-osmotic model is only to explain the phenomena that is observed, which is contrary to the conventional wisdom. But electrophoretic separation can be used for phase demixing. The way you are using acoustic, another way of using is electric field. So that's why I showed you it can be clubbed into the top of the spray column so that emulsion can be broken, so that entrainment of the one of the phase into the other does not take place in aqueous two-phase extraction when you use in a column contactor.
So,
yes, please.
So I'm Harsha Kasliwal from third year IM Tech. So it is a question regarding agricultural industry of our country currently. So it is said that most of our losses, like 60% of our losses, is the post-harvesting losses, right? So what are cheaper technologies that we can use or which can ease these things, ease these problems?
There are several. There are, as you rightly said, it is a lot of loss. That is 30% is wasted. So that is the major problem for our country. So especially when the glut is there. Simple example is tomatoes. So the area where we are living is a lot of tomato belt which is thrown on the roads. So in this incubation center project that I mentioned to you got sanctioned for 2.6 crores. One of the process line is tomato, which is a very, very simple technology, can be adopted in the farm level itself, so that farmer will get much better returns so than the thing. So like that, the low cost, low investment technologies, apart from high-end technologies, both should be there. We should cater to the product convenience foods in the tabletop products in the shelves, and also low-cost technology, which is a semi-processed raw material which can be used throughout the year for further processing.
Yes, so one more question is that processed foods are most common source of added sugar, which is extremely harmful. By exploring further advances in food processing, how we to tackle the health issues that comes along?
True. So white sugar is really one of the, it's not good for health at all. So alternate sweeteners are several people are working. They have come out with several things. There are many roots which are reported in Ayurveda. They are alternative sweeteners. So stevia is one of the alternative sweetener. So several of the even dry date powder, honey. So many things are there for alternative to sugar. And fructose rich instead of sucrose, fructose rich.
Any more questions from the students?
I would just like to answer, supplement what Professor Raghavarao said to Harsha Kasliwal. See, as he said about simple technologies which can be adopted at a farm level itself, at the same time, there are alternatives which are high-end technologies, because each of these products have got some extremely high value items. If they can be isolated, then the rest of the material which remains becomes practically free of cost. Meaning, if you are in a position to extract, let's say, beta carotene from oil, which is essentially an antioxidant which is present in it, you can separate out the beta carotene, and then the cost at which the beta carotene is sold will make this oil available to you at zero cost. Similarly, if you look at the dairy industry and look at cows or buffaloes, if you are able to harness the excreta, that is the cow urine and buffalo urine and gobar, and able to make a good composting fertilizer out of it, you have to do some processing. A slightly high-end technology is required. Then the quantum of money which you will get from these products will allow you to distribute milk free of cost, because on whatever you sell or whatever price which you get is actually a net profit to you. But you need to work at the waste, which is considered in conventional terms at waste, and convert it into value added product, which allows you to subsidize the main product. There are plenty of technologies, and you have an opportunity to work on this and be innovative and come up with these products.
Yeah, absolutely right, Professor. So when that's how they call it, when you have a rice processing, a rice refinery, they call, if they extract all oryzanol, all the other components from phytochemicals from the bran, so rice can be free. You're absolutely right.
Absolutely true.
So one more question you have, sir, that is like how far vacuum frying is commercialized in Indian industries? Can you please highlight on the other methods of modern commercial frying?
Yeah, vacuum frying is really good technology that is designed and developed at CFTRI. It gives a really good product of sensorially and oil-wise content also. So similar technology was done by this Jain Agro. They also have a onions vacuum fried. They've got a very, very good technology. Yeah, this is.
Yeah. So one more student, she wanted to know, like, could you kindly re-explain the use of heat transfer in making dosas more crispier?
Yeah, true. So what I mean to say is heat and mass transfer analysis is used for this machine while imitating what grandmother is doing. If you see the tawa, she select a tawa which is of a reasonably good thickness. If it is not thick, heat passes immediately and the darkening of charring of the dosa takes place. That's why she selects a thick hot plate. But if it is too thick, excess sink will lose the heat energy. Unnecessarily, you are wasting energy. So you have to optimize the thickness of the hot plate so that it has enough sink, enough stored energy for 10 dosas on the in the disk of a dosa machine. At the same time, type of material. Even though conductivity is more for solid stainless steel 304 compared to mild steel, we preferred mild steel because it forms a carbon coat on the surface after repeated usage that becomes non-sticky. Instead of using a chemical Teflon coating for a non-sticky, this is a natural non-sticky material and it works very well. And only problem is it deforms because of heat. So that's why thickness we have to little bit optimize and use the right thickness for this. So the conduction heating coming from the hot plate is more important rather than convective heating or radiation heating. So if you do to prove this point, we published a paper in Journal of Food Engineering where analysis was done for each mode of heat transfer. And if you do only by convection, only by radiation, and only by conduction and combination of this, there is a sensorial property variation is clearly seen.
Yes, sir. So one more question is, what innovative thoughts is given behind making square-shaped puris? Because as we know, round shapes are better as they give the uniform heating and cook properly. Please enlighten us.
Not uniform, nothing to do with heating. Round shape is conventionally we are accustomed to see that shape. So round shape. But in a machine to get a round shape, in the sheet, I have to use a disc to frank it round circles in a square. That corners will have to be recycled for next extrusion. So repeated recycling is changing the rheological properties. That's why it is affecting the product quality. So instead of a conventional puri, we started calling as a squarey. So shape doesn't matter, because after 1 or 2 generations, they accept this as a square as a food, square shape itself as a food of puri rather than round.
Square chapatis are also going to come into picture.
Yeah.
Square pizzas have already started coming into
Already coming, yeah. See, machinability, ease of machinability.
Paratha is already in triangular shape.
Okay.
Yes, sir. I think anybody else want to, students, any questions are there? Yeah, from chat, I think I have taken, sir, all the questions.
Thank you.
Yeah. Annapura, sir?
Yeah.
Yeah, as I think we have come up today to the end of this session, and I thank everyone, and especially on behalf of ICT, I thank you, sir, for giving you valuable your valuable time for us. And really, it was like a treasurable lecture for us. It's always treasure to listen to you, sir. Thank you so much, sir.
Thank you for ICT, Professor Pandit, Professor Uday, for giving me this opportunity to be with you all. Thank you very much. Always it energizes to be associated with ICT.
Same here.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you. Take leave.
Yeah.
Take leave.
Take care, Raghu.
Thank you. Thank you.
Yeah,
thank you. Once COVID subsides, please visit Balaji and us.
Yes, I have to do that. I will.
Yeah. Please. Thank you.
Hello, bye.
Bye.